depressed and they go drinking for like 7 years. And then they finally come back and say, you know what? You guys were right all along.
Yeah, it's tough that emotions are just tied to these things. This left brain, right brain stuff. Like, so you can't just talk about the facts without it triggering something, and then it becomes about your tone. You know, it's like having an argument where you're trying to talk about the facts, and they start talking about the way you're
I get
speaking.
that shit all the time, bro.
Yeah.
Oh man.
I'm trying to learn how to navigate that because it is rhetorical things. You know, need to address like the emotional side of people, and I'm kind of left brain, I guess is what you say, and so like if it hurts your feelings, it doesn't matter to me that much. I'm like, well, if it hurt my feelings and it was true, I would still want to know the truth, you know. Uh, so I try to operate that way, but not everybody's like that, and I'm trying to find a way to mix the left and right brain. Like that guy that was just in here, I was trying to talk him down and just be like, well, it's it's valid that you might look at things in the sky and think that has a bearing on what you're standing on. Like that's a valid theory, but you never validated it. You never like proved it. People don't want to feel dumb. I don't know. But then that's that. It's like, am I supposed to be their therapist as well?
Oh shit.
I kind of like the people that come in and are like, "You're stupid," and then we go, "Okay, okay, take a look at this," and then they're speechless. About 20 seconds. Start telling you that's not in a journal.
What was the one a while ago? There was a kid come in, big noting about, I've got a higher IQ than all the flat earthers. Flat earthers are dumb, like your typical crap that we get. And then
Yeah.
it's okay. Then what's the alleged radius of the Earth? And he gave some other random answer.
Really?
We recorded. It was so funny. It's actually in our backlogs. Yeah, it was a little snippet, and that shit was funny. There was myself, Roots. There's 4 or 5 of us that were on, and the best part about it, every single one of us all cracked up at the same time. So it was just instant audio chaos when this idiot gave the wrong answer. That all of us just laughing at once. It just destroyed the audio. Oh, it was beautiful. Yeah, I've got a high IQ. Flat earthers are dumb, or just the usual. And then also, yeah. So what's your alleged radius? Um, the circumference is something else. It was some really stupid answer, and it was just like, that's it. We're done.
That's funny. A self-proclaimed high IQ. That's great.
Yeah, it's crazy funny. Oh, Dylan's back.
Hey there.
Dylan's always chill.
For the most part. But I'm a glober, so something's
I
wrong with me.
know. Yeah, that's what's trouble. That's what's. I don't know if it's troubling, but it's like
The
it seems
best
like you've
part of
been
it,
here long enough to.
he only believes he's a glober. He doesn't know he's a glober.
Okay.
I'm pretty confident.
How can you
I
be
come in
confident
more.
in something that you've never seen?
It's the preponderance of evidence. I found some more
Well,
videos of measuring the curve, though. If that's what you guys wanted.
tell us about this preponderance of evidence. Outside of your television, your mobile phone, and your computer, you've never seen curvature. So why would you assume there's curvature in the first place?
I don't reject all the things that you guys are rejecting. Like I think there's conspiracies out there, but
Hold on,
yeah, the truth
unwind.
is
You don't reject what we're rejecting. So what are we rejecting?
like the standard explanation of what satellites are doing, orbiting, and
Well,
those
they've got
space
nothing to do with the
programs.
shape of the ground. So whether I accept or reject has no relevance in this story.
The celestial mechanics of things, like celestial sphere. You guys don't have a convincing explanation to me for why we have like two celestial poles.
Oh, really?
The
Well, I'll
sun
tell you what.
does
I'll tell
not
you what, Dylan.
appear to
Let's
be
let's make a
sinking into
deal.
the distance.
Let's make a deal, Dylan. The first one that goes to the star field and turns around and looks at its relative positions to the Earth can prove their claims. Okay.
The
Until
first
then,
astronaut took this.
no, dude. There's never been an astronaut that went to the stars. Never. There's never been a
Well,
probe
no.
that's went to the stars. Never.
When you say the stars, that's a whole different issue.
Well,
We've
I mean
made our
that's
claims to
that's
an
it. Is
extent.
people say the star field seems to be doing something here, and it seems to be doing something over here, and because of the things that it's doing differently, I'm going to infer something about the Earth from it, right? But that's just where we see things. You have to prove the entire geometric matrix correct, and you have to have philosophy to do it until you actually go validate it. Nobody's ever been to the stars to validate it, and I'll give you a hint. I'll give you this hint. Nobody ever will be to the stars. Never going to happen.
I know that's how you feel. I
No,
do
that's a
think that
that's a fact of energy. That's a fact of energy, dude. There's no energy that we can ever achieve that's going to take us to another star system, allegedly.
Why not?
okay, so I wasn't sure if you were actually talking about other star systems. You just meant space when you said the stars.
No, the stars, dude. Listen, going to the ISS is not going to any meaningful quote unquote space. It's basically just high altitude pretending to be space.
Yeah, I don't think that the rocket programs are going to take us even like maybe the moon. We could do some things there, but
Well,
like
even the moon, even
Mars.
going to the moon, even going to the moon isn't that impressive when it comes to quote unquote galactic or cosmic scale.
Yeah, yeah. Rockets are terrible when it comes to trying to actually traverse interstellar distances or even within the solar system. It's I mean, you can send some probes places, but that's not the way to
Within
do it. For sure.
Listen, dude, before I die, they're going to throw out the whole cosmological model, guaranteed.
Well, I promise you that they're not.
Yeah, but the problem is, dude, that you're not up on the latest science. So you're stuck in 100-year-old science, bro.
I could say the same thing about you guys. You guys are flat earthers, so I mean, as far as like
Dude,
what
what are
modern,
you talking about? Do you even know what 100-year-old science is?
what do you think that I'm
Go
missing out
ahead.
on
A
in
lot of it.
your old?
Go ahead and tell me one thing that's 100 years old in science. There's a bunch of things. For example, relativity. I think that's 115 years old now.
Yeah, there's a lot of science that's over 100 years old. I mean, when did Newton live? Like in the 1500s? So he published Principia, I think, in
Yeah,
the
but he didn't do it. He didn't do any experiments. He just did math. So that's not science.
I think he did some experiments to get force equals mass times acceleration. He used the observations of Kepler, which were um Kepler was able
Dude,
to
those are kinematics of the celestials, dude.
right.
Okay, and he used the two foci of an ellipse, and he saw the proportional mathematical equations and calculus and all this, dude. He didn't do any experiments.
Hmm.
The only
Right. I
experiments
mean,
that
you
I
have
know. Listen, friend, hold on,
Maxwell
brother.
equations.
I'm telling you the wrong. I'm telling you the wrong thing. It's not that he didn't do any experiments, because he did. For example, he drank mercury to try to shit gold. That's about the extent of his experiments.
He was what do they call them?
Alchemist.
Yeah, that's the word I'm looking for. Trying to find the
Hey, well,
philosopher's
listen, bro.
stone.
Listen, bro. Listen, bro. The whole entire thing was a woman once told him, "Why should I treat you like a king? What do you think, you shit gold?" And he's like, "Hold my beer."
He's pretty clever. I think he invented
The whole min
calculus in the early
yeah,
20s.
but do you know how that happened though? It was during a plague. He was locked up in his house basically, invented calculus, the laws of optics, and was working on the gravity with no funding or anything. It just sounds like in 18 months, it just sounds ridiculous.
Right. The optics though, there was some experimentation with the optics, I'm sure. He was
For like
probably using some
pendulums and
prisms and stuff.
conservation of energy, but definitely didn't do anything.
Yeah, we're talking about cosmological scale experiments, dude. We're talking about claims about the cosmos, not claims about, "Ooh, I have a hammer in my hand. I wonder what metal it's made out of. Oh, maybe I could do metallurgy on it." Two different things, dude.
It seems like we're bouncing around. You asked me
Oh, hold
about
on, brother. Hold on. No, see, this is the problem with Glovers. Glovers think that
Here
I
we
can
go.
do science. I can do science in my lab. Therefore, I can do science on a star a trillion billion 1 miles away. Oh, I could do an experiment in my lab. Therefore, if I write some math, I'm doing an experiment on a star. Good grief, dude.
There's a lot you can figure out from well, once you accept certain things, you can figure out a lot from there, but the you accept spectrometry, right? Like you agree that we're able to observe these like narrow band signatures from light that's emitted by different elements.
Hey, listen, dude. Spectroscopy, okay? I have the book about it. I keep it in my glove compartment all the time. It's purple hardback. And I keep it there in case I ever get hit by a car and the cop asks me what color it is, what make and model. I'll whip out my spectroscopy book and I'll tell him.
I got to use
I'm not even joking, dude. But dude, check this out. The stuff you do in a lab, again, in a lab, is a lot different than what's going on from getting light from stars. And the parts per million in a lab is actually less than what's supposedly in stars. So that means they claim to have a higher accuracy in telling what the star's made of than they do in what is in a lab, dude. The whole concept is ridiculously absurd on its face. Not only that, but it requires a philosophical assumption in the first instance, which is uniformitarianism, that everything that's going on out there is the same thing that's going on here. So if you get spectral bands that match certain elements on Earth, and then you get spectral bands from a distant star, how do you know that the star just isn't putting out those bands and it's made of a completely different material? You don't. You can't test it.
But
well,
you
when
can
you look
because
in
we know
different
what
regions of
molecules give off
space,
what light.
Oh, dude, you can't test it, dude.
But that's literally all it's doing, right? Like you understand what spectroscopy
Yeah, you're
is
dumb as a brick,
right?
dude. Yeah, you're too dumb to be here. Sorry, too dumb.
I don't think that
he
guy's
didn't even
dumb.
say anything.
No, he is dumb. He is dumb, and I'll explain.
Well, I
myself.
understand. I understand.
Oh,
but,
hold
like,
on. No, listen, dude. Pay attention now. He said you can validate the stuff that's in the star by looking at the spectral lines because the spectral line determines what's in the star. Okay? But that's not what I said. I said you can think you know based on it matches spectral lines of things on Earth. You get a spectral line from the star, but you haven't validated what's actually in the star. And that's true because you haven't gone to the star and taken a sample. Now, on Earth, you actually have to have samples, and you match those samples in a lab. And the parts per million is totally different. And like I said, they're claiming to have a greater accuracy with star-bound spectra than they are with Earth-bound spectra. That is patently absurd on its face. So no, nobody's confirmed what's inside a star. Nobody's confirmed what a star is made of. That's never happened.
I was talking about the right brain therapy stuff. I'm like he's coming with some misconceptions, and I agree with what you're saying.
You can
I'm just
get
trying to.
spectra from a light bulb. You can get spectra from a light bulb that has a coating on the inside, and it'll tell you that there's something inside the bulb, but it won't tell you what the origin source of the energy going from the inside of the bulb to the coating is. Okay, so
Yeah, I
since
mean,
I know that the external spectra can be modified, that means that at best I could only tell what the thing is coated with, not what's actually inside it. Okay, so this is
yeah,
again this idea. These people think that if I have math on paper, if I have a Google search results that said some scientist retard decided something, now I have the truth. Okay, this
the
is so
more
far removed
convoluted,
from validatable truth.
yeah,
Okay,
the more convoluted and complicated it is, the more valid it becomes. Yeah. And now that guy's gone. I was trying to get the guy to wanted to show him something. Oh well, whatever.
But when you were questioning our assumption that like the natural laws are the same throughout the universe, do you really question that? Do you really think that that's an issue, or is
yeah, it
that
is an
just
issue.
like another
It's
wrench you're
called
trying to
it's
throw?
called an it's called
Hey,
a philosophical assumption, dude. It's a bias. Okay, so
hey,
one, uniformitarianism isn't proven, and retroactive uniformitarianism isn't proven. In fact, I just listened to a lecture. No, sorry, not a lecture, a guest and a lecturer talking, and he's actually a very famous guy. He's the guy who found the computer code in the universe. And what I mean by that is he found, and when you're doing all this math on all these different things about the universe, that you end up finding what appears to be self-correcting computer code. It's identical to what we would put in a computer. And he's like, oh, how can this be? So his idea was it evolved. So the laws of the universe, the laws of physics, evolved to what they are today, much like biology evolves to have self-correcting code in the genome to prevent mutations from destroying the host. So too must the universe have evolving code. So what that means is if the universe's code, quote unquote, is evolving, and we only can see things at different times of the universe's lifespan, then if we're imputing what happens now into the past or into the future, we're wrong. And in order to impute it into the past, you have to have the retroactive uniformitarian assumption that the laws were always the same. There's no reason why they have to be. It's pure philosophy.
hey, question: Are we still talking about spectroscopy? I had a question about that. I mean, I remember learning about spectroscopy in chemistry. I wasn't like a chemistry major or anything, but like at surface level, it basically means you can use like a color spectrum to decide what chemicals are in a star. Isn't that sort of what they're saying in layman's term?
Yep.
Yes. Okay. Well, I haven't studied it that much, but could that be a flawed methodology?
Yes.
So can you explain more? Like, couldn't a color of like iron or cobalt or something easily be mistaken for another element? I mean,
It's not merely the colors. There's bands of the colors that come off of it, and they have different widths and
yeah, it's
distribution.
been a while. I remember there was like certain bands would show up for certain elements, right? So yeah, I mean, a color system can that can't. Can you explain the flaws a little more, like in a layman's way?
The number one flaw is that the accuracy they claim to get from a star, which is 1 trillion miles away, is greater than the accuracy they claim to get in a lab in controlled conditions with a sample
Where are
that's
you getting that
ubiquitous.
from? Where are you getting that this claim of accuracy from the stars being greater than what we get in a lab?
I think he said parts per million,
Say,
right?
yeah, they have a sample. They have a sample, right? And they have, yeah. Listen, if you want the brass tacks on that one, I'll have to get it to you later.
Okay, fair.
But yeah, if you look, just research how they do it in a lab in a controlled condition with an element that they already have identified and isolated as a control against the one they're testing, and how much accuracy in parts per million or whatever metric they use. I believe it's parts per million. And then compare that to what they claim they do with a star, and you'll see a stark contrast. And then you'll scratch your head. Wait a minute, how could they possibly claim to be this accurate when it comes to a star, when they can't even be that accurate when it comes to something in a controlled environment in a lab? It makes no sense.
Well, how accurate do they need to be to just hydrogen signatures and helium signatures? Like, I used to use spectroscopy with this scanning electron microscope, and I was detecting all these minerals that were depositing out of seawater, accreting out of seawater, and you can see the different crystal formations, like magnesium hydroxide crystals look different than like sodium chloride crystals and calcium carbonate.
What do you mean they look different? What does that even mean?
Well, when you're using a scanning electron microscope, you can see these like microcrystals.
A scanning electron microscope is not a spectroscopy device, dude.
Yeah, it does. It's built in. Wow. It was built into the SEM that I was using.
Okay, so then the spectroscopy thing is something else. So what does something look like, quote unquote, in spectroscopy? What does it look like?
Like the brucite crystals, for example, these magnesium hydroxide crystals kind of look like little rupees or something, and they would.
Okay, so I know now. Dude, I have no idea what you're talking
about. I definitely do know what I'm talking about.
So when it comes to spectroscopy, you're looking at spectral lines. It's going to look like a linear bar graph with different bands. It doesn't look like a crystal. It doesn't look like a structure.
That's what I remember.
Scanning electron microscope is what you can see the images. You can see images of the structures, is what I'm saying, and it would correspond.
Okay,
and
so that has nothing to do with the spectral lines, dude.
So there was their modification.
You could like use the scanning electron microscope to take images of these, even like in real time. Like you could scan over them and like, pan around on whatever sample. And
okay, then get to the part where the spectroscopy happens, bro.
Yeah, I'm waiting
for that. You could just use a tool like you would be watching on the monitor, and take a little box and like put a box with whatever part of the image you wanted to scan, and it would do the spectroscopy for you. It would come up with like all the spectral lines and automatically tell you what elements were in it would tell you like percentages of elements.
Okay, yep. So let's agree that you have the spectral lines from your sample, and then you're validating it with the image. So you're saying, okay, this spectral line says, let's just say mercury for sake of argument. And then I look through my thing and I see mercury's form that I know is the form of mercury. So I've double validated it. I have one thing that says one thing, and I have a confirmation of another type of thing that says the same thing. Now I have a double validation, right?
That's kind of what I'm getting at.
Yeah. So why don't you take your scanning electron microscope and put it on a star and tell me what's on the star?
Exactly. Exactly. That's what the next step would be, to validate that your star is what your spectroscopy claims it is.
Well, that's what they're doing. I'm not.
They're not, dude. No, they're only doing one thing. When it comes to spectroscopy, all they're doing is looking at the spectral lines that arrive with the light they receive and the direction when they point it at the star. That's all they're doing, dude. They're not doing any second order validation whatsoever. So they absolutely cannot claim for certain that they know the composition of the star. It's just not possible, dude. Without putting philosophy first. And so I would agree that in their minds they've proven it, but they've only proven it within a philosophical framework, which is devoid of direct validation in any way. Like they just have one step. They don't have a second step.
Yeah, verification is missing.
Yeah, we can't travel to these other stars.
Exactly.
But we have demonstrated fusion. We have like hydrogen bombs, and we have a pretty like.
Yeah, well, I'll tell you
I'm not.
what, dude. I'll tell you what. When
I'm
you give me the experiment
not
that
nuclear.
proves either retroactive uniformitarianism or uniformitarianism generally, you give me an experiment that proves either of those, and then maybe we can have a discussion.
What are those
That's
two
impossible.
things?
That's their philosophical framework. That everything was the same ad infinitum into the past, and everything is the same everywhere in all available space and everywhere we can see. That's their philosophy.
Some of them claim that there are other universes that have different physical laws. But yeah, in general, there are people that
Do you know
claim
why? Hold on. Do you know why? Do you know why they claim other universes with other laws? Do you know why they claim that?
because they are trying to explain this perfect tuning, why we have
Yes,
this
they're
universe.
trying to explain. They're trying to explain something they can validate with something they can't possibly prove, because they want to have a materialistic assumption devoid of direct sentient intervention, in other words, a creator. And because they are so hell bent on that philosophy, rather than accept the evidence that this world is clearly, uniquely, individually designed, they will appeal to an infinite number of universes to avoid the statistical impossibility of such a universe that we live in of existing. That's why, dude. It's, you know what? Let me give you. I can give you 4 letters. There's a 4-letter acronym that explains what they're doing. It goes like this: COPE. There you go.
Are you talking to me?
Oh my goodness, dude.
The person that just came in.
There's a lot of scientists that
COPE.
are.
That's what they're doing, dude. Coping. Go ahead.
I'm just saying, there's a lot of scientists that are theists, and don't necessarily believe in this multiverse of different
Specific
physical
theists,
laws.
specific theists do not need to appeal to an infinite number of universes to explain the order in this universe. It's self-evident that the order in this universe was designed. I mean, only somebody who's retarded wouldn't realize that, basically, or
Are you
somebody who
talking
has
to
a
me?
bias. Well, I don't know, dude. Am I talking to you? You tell me. You got a guilty conscience,
Does anybody in here do fentanyl?
dude? Just get banned.
I do fentanyl.
All right, you get banned too. You both get banned.
There is medical fentanyl. They do prescribe that shit in the
You're getting banned too.
Listen, if you're not talking about flat Earth, get the fuck out of this room right now.
I know,
Bro,
right?
no.
Are you talking to me?
Anybody else want to get muted, banned?
How about I just stay here?
All right, you can get muted too. I don't know if you're the guy, but better safe than sorry. Yeah, so the whole heliocentric paradigm and cosmological model and cosmogony model is all one giant cope session. The modern version, because actually it was the church that invented some of that. And then the atheists latched onto it, and the materialists latched onto it. Because like, this is a quote from a famous atheist. It's finally become intellectually fulfilling to be an atheist now that we have our own creation story.
Yeah, George Lemaitre, the priest, came up with the Big Bang Theory.
You want to know something funny? I did listen to a bunch of physics lectures, and one that just rolled through as I was, auto playing them was a guy talking about the universal multiverse or whatever, and that basically the laws of physics must be expressed, and they're permutatively expressed. And so every universe has different laws of physics or the same, but because it's infinite, there's something different about it. And eventually you get that not only is all of these have different, but they have every form of physics and whatever happening. And basically that if this Earth is a globe and it has a Big Bang expanding cosmology, all with dark matter and all of that, then you need the infinite universes to make up for it. But in one of those universes, guaranteed that the Earth is actually flat. So in other words, if the Earth is a globe, the Earth is flat. So then the question is, how do you know, which universe you're in? Like, what if you're, one of those universes has a flat Earth? Well, I'll give you a hint. It's this one.
But how do you think things might work if we're going to speculate a little bit then? Since there's a flat Earth, like, what are these stars? You're talking about the stars and everything. What could they possibly be? And how could this cosmos be like? Do you agree that we can observe other galaxies at all? Like, we can observe exoplanets at all?
Like, you can look at Jupiter. You can look at Jupiter and you see things that follow Jupiter that people call moons, but
right, we can see the Galilean moons with simple telescopes.
It's definitely not an exoplanet.
Yeah. Well, I'm just talking. Let's get a little closer. Let's just talk about like there's things that they call.
No, let's not do that. Let's not do that. The things that are in our local cluster, right? Those are things that anybody can just whip out a backyard telescope or even see with the naked eye, right?
Well,
but this dude's talking about things that are just dots, right? And the far out. So I would like a picture of an exoplanet, please, Dylan. And not a painting, not a render, not a artist's interpretation, not a data set that's been converted algorithmically to represent what it would look like if we could see it. I just want an exoplanet picture, please.
I don't think that those exist.
You're right. They don't. You know why?
We can't resolve that.
Yeah, there you go, dude. It's all fantasy, bro. Do you know this flat Earth movement got kicked off around 2014, 2015? You know, one of the first dudes that was going around saying the Earth was flat. His name was Matthew Boylan, also known as Math Powerland, kind of like a stage name. He was a NASA artist, and he would draw all those things. He would draw the exoplanets. He would draw all these things, and he finally realized one day after he was specifically invited to a party and someone there told him the Earth was flat, he said, wait a minute, I've just been drawing all this my whole life. I don't know any of this stuff. It's completely a fantasy, no different than if I was an artist in a comic book. Then he made a painting of the Earth. He put it on his T-shirt. He printed the words photo or painting, and he went around and asked people, hey, is this a photo or a painting? And he would ask that about all these different images. Hey, is this a photo or a painting? Is this a photo or a painting? Is this reality or a fantasy? Dylan, we had a physicist come in here specializing in locating exoplanets. He showed us an image of one of the exoplanets he found. It was an 8x8 grid of pixels, or it might have been 16 by 16. But everything in it was just a blur of gray, white, and blue pixels. And he said, you see this pixel here when it flickers? That's a planet orbiting around a sun. And I know how big it is. I know how many mountains it has. And I'm like, dude, you don't know any of that. You're just interpreting that from math. And that math is based on your assumption of orbits.
Did he claim that he knew the mountains around it? I don't think he was claiming that.
They claim a lot of stuff about these worlds, and that's why they make these images of the worlds. They take what they think they know, they give it to the thing. They'll tell you that one of these worlds is like, has more mass in the upper left quadrant and stuff. And they do it based on the pixels, and they assume the pixels' motions are orbits, and that if it flickers dark, it's going behind something. And they create all these models. Now, they create it out of the orbital elements. And the reason why they do that is because they've interpreted the ones local to the ones far. Now, what's interesting, though, is I asked him about the math of the orbits and stuff. And I said, well, how do you know that? And we kept going backwards. Till finally he got, well, we know it because we know how the Earth orbits the sun. And we know one AU is the distance from the Earth to the sun. And I said, well, how do you know that? Like, what's the first rung of the cosmic distance ladder? And he didn't know the answer. So he didn't even know the answer to what his entire field was based on.
1 AU is like the distance from the Earth to the sun.
Right,
Yeah,
but
to
1 AU is
drive
not a value.
It's a distance. 93 million miles or whatever.
No, dude, 1 AU is just whatever the distance is to the sun scaled. Once you put the 93 million miles, you can then use the proportionality to get other things. But how you get the 93 million to get the 1 AU, that's the first rung of the cosmic distance ladder. And he had no idea how that's done or why they even assumed it in the first place. He didn't say, oh, Chris Huygens, went on this trip to watch Venus transit the sun, and then assume that the Earth and the Venus were the same size, and then get the time and the scale, and then do that into this math and blah 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 blah.
He didn't even invoke transit of Venus.
No, he didn't know anything about it, dude. He's
didn't
supposed
get
to
that far?
tell me. He's supposed to tell me that this planet has water on it, and maybe one day in the future I could live there and be a barista, and have an alien wife. And then he doesn't even know anything. It turns out he knows absolutely nothing. He's just applying a mathematical model that he learned in college, and then he went on to get hired by some company that rakes money out of the gullible taxpayers.
Well, we're supposedly going to build a moon base here soon, so you guys will have to explain that one.
That's going to be exciting.
Moon base doesn't mean anything, dude. It has nothing to do with the shape of the Earth.
Well, they can take pictures from they're going to be able to view the Earth from there. I'm just saying it
Dylan,
should settle the argument.
Dylan, they could make a moon base. They could make a moon base and staff the entire thing with people that are entirely agents, and you wouldn't know. They'd have backstories about how they're normal people, but they'd all be agents. You wouldn't even know, Dylan.
So, yeah, you guys will.
Yeah, we were just talking about the transit of Venus. Are you familiar with that one, Dylan?
Yeah, I saw it in 2008.
Okay, good. So, that's sort of like the fundamental that is invoked when people talk about distances to stars and to the sun and things like this. That's the measure they use.
I'm not actually. I don't know how they figured out how far the sun is.
That's a really good question, isn't it? Then, so that's how they say they verified the distance to the sun. But then, people will go that far and they'll say, well, we use the transit of Venus. But then if you ask them, how did you verify the size of Venus to measure the transit of Venus across a body? And usually they run away at that point. See if you can get an answer for that.
How we calculated the distance to the sun?
There's no answer.
The size of Venus to do the transit of Venus. So to perform the transit of Venus calculation, you need to have a size of Venus. So how did you measure the size of Venus?
Oh man,
I don't know that one either.
If he finds the right answer first, it's gonna blow his mind.
What do you guys think the answer is?
we already know the answer, but I don't want to tell you the answer because it's actually better if you find it for yourself because it is literally like finding out you were adopted, dude. That's how profound it is. It's gonna blow your mind.
Answer, but I won't say anything.
Yeah, it's gonna blow Dylan's mind because Dylan thinks all this stuff is based on science. And so when he finds out what this is based on, his mind is going to jellify and come out his ears.
Yeah, it's like everything might, at a cursory glance, look so cohesive in all this astronomy and stuff. But the thing is, if you build everything on the same assumptions, then of course it'll look cohesive. I'm 90% sure I know what the answer is. Let's see what Dylan.
It's like Morpheus said, no one can show you the Matrix. No one can tell you the Matrix. You have to see it for yourself. Give you a hint though, Dylan. So like back in the day when they first started positing that the Earth was a globe in any meaningful sense, the people who were positing it were vegetarian cultists who believed, for example, Pythagoras, that the creator would create a perfect world. And the perfect shape is either a ball, a testicle, or an egg, all of which are roughly the same shape, depending on which, form they take. And these were the symbols of creation, the symbols of perfection. Same with space. Nobody discovered space. Space was thought about philosophically before it was quote unquote discovered. And they were thought about for religious reasons.
Are you joking, or did they really invoke a testicle? Are you just, is that just a joke?
The divine shapes are either the testicle, the egg, or a ball. Now, the reason why the testicle and the egg is because
like Pythagoras. I know he was into spheres, but like literally, he was talking about testicles.
No, I don't think he did. I don't think he did all three. But different people thought of these ideas, and these were their reasoning was the symbols of creation. Right? The egg, the sphere. Spheres are perfect shape because it's got the same radius. It's got certain qualities to it, and obviously the egg and the testicle has to do with divine, not necessarily divine creation, but creation in itself, right? And so depending on which you take the matriarchal or patriarchal view, you would assume testicle or egg. Some people think that women or mothers are the givers of life, but that's not necessarily true in every philosophy. So, for example, in Christianity, everything comes from a man. Everything comes from the male. Women don't create anything. Rib. Yes, the man was created directly by God, and then God created the woman from man's rib. So everything that's human after Adam was created by Adam, or came from Adam, not from woman. Even though he called her Eve because she's the mother of all that would live, he is the father of all that would live, even Eve.
Okay, so I looked up the method that we use to calculate the size of Venus. It makes sense. So
when did they do it?
Yeah, which year are you talking?
Yeah, we don't want the post.
This is a sequence.
We want the instantiation.
Yeah.
To it, so.
there's hundreds of years in between where they, calculated originally the size and then used later methods like radar
We don't
in
care
order
about the
to
later
confirm.
method. We don't
Yeah.
care
So the
about the later method.
original method used parallax. 1761 and 1769, there were transits of Venus, right? But they set up observers on different parts of the Earth
My goodness.
to measure the relative angles that they're observing this transit with, and basically the parallax method is the same way your eyes work to register distance to an object.
1700s. You said this. You said the 1700s.
Yeah,
Okay, so this is not Huygens then. This is not the guy who did the transit of Venus that they use for this distance ladder. Okay, so you still got to go back further, brother.
mm, how far back do you think I should go? I mean, this is what came up when I asked how they did it. So
We're talking about the origins of the cosmic distance ladder. Okay, so you can't bring stuff that come after it's been established.
I don't think that they had a good cosmic distance before the 1700s.
I'll give you a hint. I'll give you a hint, dude. It's Christopher Huygens. Okay.
Seems like he did a lot. Yeah, it's saying that he guessed that Venus was roughly the same size of Earth.
Get that? How do you get that? Come to that guess?
That's just a lucky guess.
No, it wasn't a lucky guess, dude. He came to that guess for a reason. Think about it, dude. You're just looking up in the sky and you're seeing objects, which you have to assume that those objects are relative to the Earth at all. So you have to have some kind of cosmological model in your mind already. But then to then jump to, oh, that object that I'm looking at, which clearly I have no telltale signs of how big it is. It's just the same size as the Earth. It's a good guess. So I'll tell you the secret, since you're probably not going to find it, since a lot of the actual history of how the globe Earth came to be in the modern day is whitewashed. You have to go to actually primary sources. You can't just casually search it. So how he came to the guess, dude, is the occult. I think he had a vision of some kind, or he did some kind of seance or something. There seems to be this weird trend of dudes involved in the heliocentric quote unquote model that we know and love today. They're always involved in some kind of religious experience in the beginning.
AI overlord. Can any of you, with at least 100% of your brain, confidently prove the flat Earth?
Sorry.
Wait, I want to give.
Using 100% of your brain would be lethal. You can only use a certain amount of your brain simultaneously because of the calorie burn. Your brain would overheat and you'd die. So you're too dumb to be here. But homie wants to talk to you, so I'll let you. But remember, don't try to use 100% of your brain. You'll die. Go
I'll
ahead.
show him, but
Well,
just
I mean,
to continue.
you'll die from the dumbness of your theory, yeah. I mean, if that's what you think.
No,
Unless you're
I'll
able
show
to
you
see.
something cool. What's your name, Master? All right, I'll show you something cool in just a second. But just to finish that thought, I was trying to get find what you're talking about. He had a vision of a hot tropical world on Venus where there were aliens and things. Is that what you're talking about, AI?
No. In this world that you live in, I'm assuming you're a flat earther. And in this world you live in,
Oh no, we were talking about something else. Sorry.
Oh.
All right,
okay.
we can jump to your topic, which is the main topic. But we were talking about Venus, and I wanted to know AI, like the crazy vision this guy had. But anyway, let me just blow your mind real quick. All right.
Yeah, blow my mind.
Are you on? Are you driving or anything?
As of right now, no. I'm just laying down.
Are you able to look at my screen?
Oh yeah, I can look at your screen. That's no issue.
So, right, run through this. I'm gonna do this in like 30 seconds, and then I want to hear AI talk about that vision or whatever.
Testing the glow. Wait, go ahead, please.
Yeah, so like what we're talking about here is geometric. You're asking for proof, right? So
Yeah,
it's a geometric question. It's a geometry question. And so what we have to do is measure things and observe the Earth to find out what it is. And so we call these the naked emperor observations because I don't know if you had this one in elementary school, The Emperor's New Clothes. Remember that book? Anderson tale. Two swindlers sell an emperor clothes they claim are invisible to anyone unfit for their office, so no one dares admit they see nothing. So he parades naked past a crowd too invested in the story to break it, till one child says it. The discovery wasn't new data, it was just permission to say it. So for the flat earth, you don't need a new observation, you just need someone willing to say it. The globe makes a specific testable mathematical prediction about what you can see from any height at any distance, and we've got tests and counterexamples to what we're told. You know what a radius is, right?
I'm aware of what a radius is.
Okay, and you're looking at my screen? You can verify this. Okay, so the globe, NASA, the way they shoot the rockets, everything, 3,959 miles is the radius they all claim. And from that, you can determine geometric elements of this shape we're on, such as a sagitta. I'll show you what that is. Not a lot of people remember that from geometry, but I'll show you. And hidden height, it's another calculation you can do to determine if something is below the line of sight at a certain distance. So sagitta is basically the height that a water will bulge on a globe that's, mostly made of water. So we do these tests over water because it generally seeks level. And what we end up seeing is this chord, actually. So there's an arc that's missing, and the sagitta is the height of the object of that arc. And then you've got this thing called geometric horizon, which starts to block your view. If you're truly on a globe, at a certain distance, you'd have a blocked view because of this geometric horizon. You following so far?
Yeah, I'm listening as of currently.
All right, so there's a geometric horizon right here. This is what it would look like, right? On a globe, it should be your horizon. You're looking out at it, and then where the sky meets the sea, that's got to be where your globe starts to curve off, right? Where the bulge is that we were just talking about. So let me just jump to the last example because we have a lot of observations where that bulge is not there, but let's just use a laser. So FE Core, they went out to look at basically GPS is based on a lot of different models, but one of them is WSG 84, and they were looking at data points in that, and they created this high-powered laser called the Super Accurate Laser Aiming Device, and it's accurate within a micron. This is like a $30,000 build with GPS targeting precision on it, and a micron is about the width of a hair. Okay, so it's that precise, but it didn't really need to be that precise, but it was. And what we did is they shot that laser across a 25-mile distance, and you can see in these images here where it hits at ground level. It's hitting a target right above this woman's head here. And this 40 kilometers distance, that's about 25 miles. So with the math I just showed you, that's a problem, because what we're seeing is at 4.9 feet, we're able to hit a ground level target with a sagitta that should be there based on the 3959 mile Earth radius. Sagitta should be 103 feet, which is the size of Christ the Redeemer. So basically you're firing a laser that is, you still believe the globe, it's going over this object to hit ground level 25 miles away.
Okay, interesting.
You see
So,
the problem?
okay. Yeah,
You-
sure.
So this is one of many observations that have been made. So this is a tested, measured thing. And the reason it's growing is because people are measuring and observing large distances with modern technology and finding that there is no sagitta, no bulge that would be required on a globe 3,959 mile radius.
Yeah, that's very interesting. So you like math a lot, right?
Not really, but why do you ask?
I'm just out of curiosity because I have a lot of math and I will prove a lot of things.
This isn't measure. This is a measurement, not math. I mean,
Yeah,
it uses math,
yeah,
but it's
it still
not.
requires math, which I have math that can prove many things about the globe. If you would like to hear it after you're done, of course. I'm still listening. I'm just letting you know.
Does it prove that there's curvature?
You want to hear it?
Sure.
This is just one question before I start. Do you know how to measure the sun's angle between two cities?
The sun's angle between two cities. So I have to make assumptions about the sun's distance. Why don't we just measure what we're
asking
seeing?
a very simple question. It's a yes or no question. That would suffice. Thank you.
We can measure angles to the sun. We were just talking
Okay.
about the sun's distance. It's funny you bring that up.
Yeah, exactly. That's why I want to mention it because I heard you mention that. Now, unless you see,
I know where you're gonna go. No offense, we've heard a lot of this. So let's pretend you're.
Listen to what. No, I already listened to everything you've been saying without interrupting you. So if you would like me to give this argument or concede, then that would be nice. So you want to hear the argument? Okay. We're gonna use city A and city B as examples. City A is directly under the sun at noon, aka the sun is overhead. So guess what? A vertical stick casts what? No shadow. Is that correct or incorrect?
Yeah, I mean, if it's right above the stick, yeah. So you're invoking Eratosthenes, right?
Yeah, exactly. Yeah, exactly. City B
Yeah, I do know.
is due north
Like I was
of
telling
City
you.
A. Yeah, exactly.
Yeah.
So you're aware of the
So
7.2 angle, correct?
yeah. So you've got angles with sticks and shadows. We've got lasers and
Okay.
optics.
Now let's measure the distance. Let's suppose both of these cities are 500 miles apart.
Mhm.
If 500 miles is 1/50 of Earth's circumference, all we have to do is circumference equals 500 times 50 equals 2,500 miles, correct? Just to confirm that I'm right and you
Listen.
don't have it here.
So
What do you mean,
so
listen?
what's the distance to the sun in your measurement?
But hold on, did you hear what I just said? Really quick.
Well, I just want to make sure you also have calculated the distance to your sun, and that you verified that, because that's important.
Okay, so hold on, let's do the calculation right here.
Yeah, but you just brought in a number. Where did that number come from before they started measuring? Like you said, you just take the
Are you
circumference.
talking about the 500 miles?
radius, right?
I put that in.
Yeah, but where did they get that number?
Where did they get the 500 miles apart number from?
No, the radius or diameter of the Earth.
I haven't
You
even
said you
done
just.
that.
Well, you got to have that before you measure the shadows, right? So they just put in a number.
So you want to know we're solving the radius as of currently. That's what we're getting towards. So
How do you know the diameter to solve the radius?
So hold on. So did you just join the room, or did you just join the conversation?
Oh, I listen lots.
So you listened the whole time. So what did I say? What's the very first thing I just said? Okay, so you weren't paying attention. So don't join in.
You were talking about Eratosthenes. I was just asking, how did they? You said that all you need to do is you take the circumference and the radius or the radius and plug it in. But where did they get those numbers to plug in to do the measurements of the shadows? You gotta explain where that number comes from first.
He left.
Well, it's just an assumed number, right?
He left. Always, dude.
That fella had
Yeah,
so much confidence going for
They
him.
always leave.
Ran right away.
But it's supposed they think you're teaching you something. But anyway, I do want to hear AI.
He's back.
Oh.
My phone died. Hello?
Oh, hello.
Yeah. Let's continue.
So restate
So
your
where did they
argument,
get
because
that
you left.
number?
Well, that's what we're solving for the radius. So how am I going to say radius when we're solving for it? Whoever said that earlier.
What circumference are you using to find the radius? How do you know the circumference?
Well, the circumference is 2,500 miles, and we're doing this based off the calculation pre-assuming that both of these cities are 500 miles apart. Which
Right, and
500
then
miles.
You measure some angles of some shadows with sticks.
Yeah, this is based off Eratosthenes. Research.
Yeah, but Eratosthenes picked the number, right? He put in the circumference, right?
No, he put in
measure shadows. You need that number.
He put in the sun's distance and size.
Yeah, he never.
Which how did he know the sun's distance?
All right, wait, are you asking me, or is that like a hypothetical?
Yeah, that's you. That's one of your numbers you need.
Okay, so you want me to put in the number? Okay, I got
No. How did he know that? I mean, that's a big part of that.
Oh, you're asking how
sticks
did
and shadows.
The sticks and shadows. I mean, if you want me to go back to the book and show you, I can. But I'm gonna be honest with you. I remember all of that off the top of my head.
That's fine.
That's because it's been
That's
a while.
fine. They intentionally wrote that lesson for you without including how he calculated the distance to the sun.
You don't need to know the distance to the sun per se, because you could assume it's infinite. But you need to know how much 500 miles represents of the Earth.
Yeah, exactly. That's what we're getting towards. And with that whole, equation that I was doing right there, it will add up to about 24,901
You
miles.
left out a whole bunch of steps, dude. Holy crap.
What did I leave out?
Okay, you said it's 500 miles away, one city to another. He got angles at one city and angles at another city. That's all you have on the table so far. You have A, you don't have B.
I have A, I don't have B.
Yeah, you're going A plus B, therefore C, but you didn't talk about the B.
I didn't talk about the B. But this is saying
Yes,
both.
dude. What about different angles with a city that's 500 miles apart from another city has anything to do with calculating a globe radius of 24,000 miles, dude?
The thing is,
Listen, I'm gonna leave it to Normal Rat to chew on the peanut butter, which is the mush in your brain, to see if you can ever get the answer.
What we're getting at is that there's a lot of assumed numbers in the Eratosthenes story. Also interesting, like, how did he measure the same day? $500 miles away.
They had a can with a string on it to the other guy.
Yeah.
Look, he didn't have to communicate directly. He could have sent somebody else and say, "Hey, on this day, measure," and then they met later on and conferred their results. So that's not really a defeater per se.
I know, it's just interesting that it's all attributed to him, but and he could have done it a year later, the same spot. I mean, he could have done stuff like that. True. Anyway, the point is, like, if you want to speculate where the sun is, that was never verified in the first place. So if it was closer, it could also have those results on a flat plane. Just jump to the conclusion. And now AI, I want to hear that crazy dream that Christopher Huygens or whatever his name had. What's his name? Christopher Huygens? He basically had an occult vision that he saw Venus. That's what our transit of Venus is based on.
Dude, I'm trying to do some electrical work. You're supposed to be taking the show.
Oh. All right, you enjoy your electrical work there, AI. I gotta get going. It was a good night. Bye, everybody.
So what was wrong with the parallax method for determining the distance to Venus? Because I looked up Christopher Huygens, but that was just an earlier method, and he lucked out with guessing Venus's size is the same as Earth. But when we use parallax and the angular resolution of Venus, once you have the distance and you know the angular size, you can determine the actual size. And parallax is pretty simple geometry. When I brought it up before about trying to calculate the distance to the sun based on the idea that the Earth is flat, it seemed like the only issue was that you guys were claiming that the sun might not be a physical object, and that rules of geometry don't necessarily apply to it, but
You realize your own model requires that of the sun already, right? Requires it to just be at an apparent position. To explain away things like solenoid eclipses.
well, refraction explains the solenoid eclipse, right? We have explanations for that. It's not impossible.
So, would refraction make an object to appear to be exactly where it is, or no?
No, refraction means that it appears to be somewhere other than where it is.
Hey, then it's not geometric then. Can't have it both.
Well, yeah, I mean, if you're saying that celestial observations like are always going to be off because of the refraction, like celestial navigation wouldn't work. There's methods for avoiding refraction when you're taking celestial observations by and looking at stars that are far enough above the horizon. You don't take sights on stars closer to the horizon. I don't remember the rule of thumb that they use, but you're supposed to, I think it's like over 25 degrees up, something like that. And those observations were taken, higher than that. Seems like you should be able to calculate the height of the sun, right? If you know that based on time zones, like one person is observing the sun directly overhead and at a known distance away, you can observe it at some angle. You should be able to calculate the height of the sun from that. Do any flat earthers claim to know the height of the sun?
None I've ever came across in here. That would be pretty foolish claim to, think you're certain about.
I'm sure there'd be some margin of error, like with any kind of calculation, but I'm surprised that there's not more flat earth science in that way. Like once you claim to know that the earth is flat, like it seems like trying to figure out what else is going on. Seems like
Oh no,
I saw somebody.
there's people that are doing that, but that's not what this place is for. And, you know, that's the realm of speculation, right?
Well, there's certain things that would be measurable, like coming up with a map. That seems like something you'd want to do, and it's sort of verifiable.
So how relevant is that truly though? Like how can these be, as far as determining whether it's a sphere or not? Like none of those even compare to trying to measure the surface of water at rest, do they?
No, but I'm saying you already know that the Earth is flat, and you know, and I'm using like in air quotes here, you know,
I got you.
if you know that the Earth is flat already, and you've thrown out the other models that we have in mainstream science about the heliocentric model. There seems like
Why would we be so interested in making models to replace a model that couldn't be scientifically validated in the first place? Because the things in question can't be accessed to know certain things about them. So why in the world would we then try to make another model to replace the other model? Like this doesn't even make sense, dude.
it seems like having an explanation for the world is something that you'd want, besides just knowing that
No. Okay, that's great. But the cosmos is not the world. The Earth is our world. The cosmos is not our world.
I saw somebody posted something a while back about trying to gather people together to make a map. The height of the sun seems like that's something that you could calculate. The height of the moon. If they're not what's claimed to be, it seems like you have some interest in verifying what they actually are.
Dude, what method are they going to use?
Couldn't you just
Same
triangulate?
method that the globe used? No, you can't just triangulate, dude. You can't triangulate the celestial objects, dude.
Why can't you triangulate them?
Because the only thing you have is the arrival angle of the light, and you don't know what's going on between you and the object. Okay. Not only that, but yeah, I could give you a video right now that says you can't even get 93 million miles for a sun trying to triangulate it from angles from cities. So you can't even triangulate the sun on globe Earth, let alone on the flat Earth. You just can't do it, dude.
Well, you're saying it's much closer, right? And if you
Doesn't
assume
matter.
you're saying that all of these
Doesn't matter. Listen, Dylan, let me help you out. Let me help you out, dude. The lines of sight don't intersect to a common point, whether globe Earth or flat Earth, dude. Okay?
Right. I remember you telling me something about negative parallax.
Yeah, dude. In order to make these geometric assumptions about the cosmos, you have to impute spatial relationships that occur in like a room in your house onto the cosmos, and there's no way to validate that. When you try to actually do it, you can't even do it. Even when it comes to parallax that they do now with the globe, they don't just do it raw. They wait 6 months because they assume that the Earth is on the other side of the sun, and they add that into their base leg in order to get a variable rate that's big enough to measure. So even that requires assumptions, which by the way requires the AU, right? So you have 2 AU because now the distance from the sun multiplied times 2 is your base leg, right? So it all goes back to assuming the AU in the first place. So the parallax measurements that came later are based upon the first order assumption of Venus in the first place. It's one big giant circular reasoning.
Right, but if you start with assuming that the Earth is flat, and you know that the sun is overhead at one spot, and you know the distance to some other location where the sun is not overhead, you could take the site of the sun from the other location and the distance and triangulate the
Yeah, that's a cool
sun's.
story, dude. It's a cool story. It doesn't work out in reality. It doesn't work for globe. It doesn't work for flat. It doesn't work for triangle. It doesn't work for octahedron. It doesn't work. Okay, at best you'd be creating a model on a piece of paper. That'd be all you'd end up with. Who cares about a model on a piece of paper? You can take your model on a piece of paper, crumple it into a ball, light it on fire, and throw it in the trash can where it belongs.
So there's no reason to ever come up with a model of reality.
Goodness, dude, it's not a model of reality. It's a model of your visual world, which isn't necessarily reality. It's just interpretation. It's basically an interpretation, dude.
Right, but there is some truth, right? You agree that there is an objective truth.
Listen, if there's an objective truth and you try to model it, and then you reify your model claiming it's objective truth, you've just committed a logical fallacy. So what do you end up with? You end up with a bunch of logical fallacies. Okay, it's a fool's errand. Okay, see, I know that you're suffering from the delusion that the globe model is an accurate representation of reality, and therefore the model is reality. And you've been taught that, and you don't even recognize it's happening in your mind, but it is. The people who know better can see it clearly.
True.
Okay, you got to get it out of your head that models are reality, dude.
It's brainwashing.
Just got to take that idea.
I'm not claiming that models are reality. I'm saying it seems to be like if you're curious about the world, that you'd want a relatively accurate model, like to explain reality.
Whatever, dude. You're just going in circles now, dude. You're just back where you started. You haven't progressed in this conversation not one bit. And that's the problem, is people like you think in circles. They think in circular reasoning. So it's impossible to carry you down a logical progression that results in you ever learning anything, because you need the circular reasoning to live on the globe.
But I'm saying, like, if you're just open-minded about what reality is, I mean, that's sort of what science is. We try to, there are things that we do know that we know, right?
Dude, let me help you out, dude. Let me help you out. Science is not a tool that answers all questions. Okay, period, end of story, full stop.
So it's just unanswerable, you're saying?
Yes, there's some questions that are unanswerable because they're not tangibly accessible to the tools that we have. You can't do science on the cosmos, dude. Cannot be done. Nothing up there is tangibly accessible for us to do tests on.
Could that change in the
any
future,
scientific method type of sense.
Could that change in the future?
I mean, theoretically, it could change in the future, sure.
Okay.
So again, we're back at theories and ipso factos and appeal ex ante, which means to the future.
Why is an accurate map of the world so impossible to get?
How is it accurate, though? In what way? How would it be accurate?
That's a great question.
Accurate to whose standard as well?
Or accurate to what purpose as well?
Well, the map is just showing you relative distances and locations, like positions to things.
Based on what? Guessing?
Well, I know how we've come up with maps for the globe. I mean, you agree that their navigation is an important, like,
What's the
task.
first step? What's the first step? What's the first step to make a map of the globe?
You need a coordinate system.
No, you need an assumption the Earth is a globe in the first instance.
Well, I'm saying assume that it's flat.
A
submit a
map of
plot
the
then.
world.
Yeah, we
What
have
I
maps
can
of the
assume
world.
here, I'll tell you this. Here's what I can assume, which is actually true, is there's no single synergy for all the maps in the world, with the exception of an attempt to do it with the celestial sphere. Because the things in the sky, like the celestials, can be seen from vast distances where any other demarcation cannot. And so they attempt to synergize all the maps into a worldview based on the celestial sphere. And the artifacts of the celestial sphere is why you end up with a reverse engineered coordinate system trying to impress the celestial sphere onto the ground. Because that's the way they chose to put all of the different parts together. Because there can be no standard that they just like truly, dead reckoning ipso facts, real measurements. Now that may change in the future. So for example, there's allegedly coming down the pike a atomic gyro which will be able to chart its course in free space absolutely. So in other words, it can tell you that it went straight, it went left, it went right, it rolled, it yawed with almost perfection precision. And so they could just, take one of these over the surface of the earth and it would tell you the contour. And whether it was curving, whether it was straight, at least in theory, that's what it could do. But until then, all you have is local measurements that you input into a model, like a geoid or an ellipsoid, or you get Helmert's 2-page volume, 1,600-page mathematical equation book, and do all these conversions based on the assumption that the Earth is a sphere and it has gravitational mass and rotating. And then you have to curve the plumb lines. You have to synergize the celestial sphere measurements with the deflection of the vertical. You have to reduce the horizontal. You have to put it on the ellipsoid and then to the geoid. And then you have to take those 3 different measurements and then average them out with like 500 pages of formulas until you get your conclusion. So no, my friend Dylan, there is not this just magical, accurate map of the world that just is, we go and measure it and know exactly what it is. No, that don't exist, friend. Dylan, if that existed, then all of these synergies and maths to transform the raw measurements into the models wouldn't have to exist. You would just measure it as it is, write it down as it is. It wouldn't be any of this extra nonsense. Like right now, I can measure this floor for you. I could take my tape measure down one end, down the other, down the other, down the other, use the 3, 4, 5 rule, get straight edges, make sure, and then I could tell you that this angle is off, so I have like a little triangle added onto the square of the floor, and I could tell you exactly what this floor measures. But if I wanted to measure this floor and the floor, down the city, I'd have to have a way to put them together relative to each other, right?
Yeah, the Romans had like a device that they were using to make early maps where they would basically like an odometer. They were just measuring the rotations of a wheel.
Do you know what's hilarious, dude? The name of that thing.
The original Roman one. What was it called?
Memory. Something like lenticulator or something like that.
When I used to work with AVs, we would use these
Dude,
ADC.
I'm gonna post the word here. It's from the Latin,
Seems like
dude. So the word means to walk through, and that's what they named it, the walk through. So here's the word, perambulator. It's a perambulator. Oh,
it's a good name.
pretty funny, huh?
That's what I'm saying. They didn't have the internet. Like they didn't have shit compared to what we have as far as information systems, and they were still interested in coming up with a map. seems
Space
like you
Ranger
could
said, what about direct surface distance and angles? There's no direct surface distance on a globe, bro, because it's
sur-
curved. And then you got to take
surveyors are
into effect all the relief, and you got to take into effect the deflection of the vertical and all that, et cetera, ad infinitum. It's not just simple and direct. You'd like to believe it is in your imagination.
there's going to be some margin of error with any kind of endeavor to measure anything, but
This dude
it
just said
seems
you
like
can measure distances in a straight line, but he's going over a curved surface. Holy crap, dude. That's not a straight line, dummy. That's a curved line. But anyway, I'm going to stop answering this guy in the chat. Go ahead, Dylan.
well, like I was saying, surveyors are making maps of different regions. Seems like you could kind of tie these regions together. Like we have pretty accurate survey maps, and you just tie these things together. Seems like the maps we have are pretty effective.
What's the most effective map?
Well, like you said, it depends on the purpose, but there's charts for navigation. We have it seems like navigation is the main purpose of a map, but it could be
To some degree.
for
What about targeting?
in a sense
I
that's a
know.
form of navigation.
I mean, you could argue that. I guess you're navigating the round to the target. Yeah. So go ahead and give me the most accurate map by tolerance of the greatest region that could be validated directly without having to assume a model in any way, shape, or form. That way we can validate the accuracy of that particular map to the location that it describes.
You gotta have to have a model though in order to have a map, in a sense, in order to be effective. Like this Mercator projection, like there's the globe and then there's these other projections of it. But if you're assuming, if you have a map, you have to kind of assume either it's flat or it's a globe. I don't think you can get away with having no assumption of the the nature of the surface you're trying to make a map of. Sort of built in.
Yeah, you can. You can assume it's flat up to 200 square miles. Do you know how I know that?
You said do it without making any assumptions of the surface, though. And I'm saying, yeah, if you're assuming it's flat, then
you operate, dude. You listen, friend. Let's be clear to each other, okay? Let's not bullshit each other here. Okay, let's be frank. Everybody operates in where they go and what they're doing as if the Earth is flat. Your eyes work as if the Earth is flat. Your relationship to the horizon, horizontal, vertical, is as if the Earth is flat. Everything you experience as you're going around your daily life is practically as if the Earth is mechanically flat. Like that's just a fact. Now, Globers will then say, well, that's true at a local scale. And it's not till the bigger scales that the size of the Earth starts to take effect. So it's already agreed that we all experience the Earth as flat. It's not until we go into these big things that it matters that it's a globe, allegedly.
Yeah, I agree with that. in a sense, there's projects like that CERN project. They say they have to account for the curvature when they're building certain projects.
What's the deviation they had to account for and why?
In order to maintain these like straight laser paths, they couldn't assume that
No, dude,
the
laser. Look, they put the laser in a vacuum tube. It's gonna go straight. As long as the tube, the laser in it is straight, it won't hit the walls, which is what they care about, right? Or the beam or whatever. They don't want it to hit
right
the walls. All they want, right? So all they have to do is make sure it's straight. So how does making something straight have anything to do with the curve of the Earth?
when they're constructing this device, if it's over this long period, these long regions, and they use depth from some elevation. If they're using a flat map, then they're going to get a certain depth for this laser beam, right?
So
But if
that's cool. So how did they do it then? How did they do it? How did they mechanically change their construction or the Earth to do it? How'd they do it?
the depth of this laser is at a certain angle, where
Really?
they
Not even a laser, dude. But anyway, I'll let that slide.
right, the beam, these particle accelerators, right? They're trying to get a straight line path for it. So they have to, if they're going to send this, they're going to build this device, it's going to have to be set at a certain angle, like based on the curvature, right? So if they want to be able to have some part of the structure near the surface at different parts of the structure, then it's going to have to
I don't care. I don't care.
to
I don't care.
cut through
Hey, Dylan, I don't care about your woulda, shoulda, couldas. I asked a question that said, how did they mechanically effectuate this in reality? I didn't say your hypothetical story.
Okay, well, like there's a little documentary about how they did it, and it
Well,
assumed a curve.
did you watch it? Did you watch it?
I didn't watch the whole thing, no.
Okay, well, the part you watched, you certainly didn't tell me anything useful from what you said. And so whoever did the documentary clearly is a dumbtard and didn't actually take the time to effectuate telling you what they actually did. Because if they did, you would know it. Unless you forgot.
Yeah, I probably forgot more than I remember. But the point was, the claim is that they did have to assume
Well,
a
I
globe
agree.
for that.
Yeah, I agree, dude. Listen, friend, I agree. There's a whole lot of claims when it comes to the globe. I agree with you 100%, brother. You know what's funny, dude, is they even have this little GIF that you can pull up on Discord when you type in claims in the GIF section where they're going to post it, and it has this nun walking down the street with a bell, and it just goes claims, 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 claims. You know what? I'm going to post that right now.
You guys are pretty quick with your gifts.
Well, dude, somebody on Discord and had that GIF implanted in to the quick search, so enough people posted it where now it's just quick searchable. Don't even have to get it from an external source. It's within the Discord platform GIF button. The theory and the claims about a lot of these structures, dude, sometimes they fall apart under scrutiny when you actually look at what they mechanically did in the actual world. Okay? The actual building, the actual thing, the actual digging, the actual structure is often much different than the claim. And so the final structure is all that matters, frankly, not the claim. And then there's another part to that, which is if the structure is irrelevant to where they had accounted or not accounted. Because there's always this claim that you have to account for the curve of the earth or the thing wouldn't work. A lot of times that's actually not true. You could have just ignored this alleged curve of the earth and you would have got the same result. My personal favorite being the Verrazano Narrows Bridge, allegedly is 1 5/8 inches out because of the counting for the curve of the earth, which is absolute nonsense. And then my second runner-up is the toe tank argument, which Mr. Sensible of relatively low YouTube fame and then Dogs Are Gods both tried to present here and got absolutely train wrecked into oblivion. Turns out that the mechanical, see, they had all these claims about the accounting for the curve of the earth in the toe tank, but the mechanical action that they actually did was they filled the trough with water and then they paralleled the rails to the water. So there's no accounting for earth curvature being done. It's just leveling the rail. That's all it is. And even if it was supposedly accounting for the curve of the earth, the difference in the rails is less than a width of a credit card at the center of the rail versus the end of the rail, which means that distributed over the entirety of the rail would be irrelevant to what they were trying to do. So even if some retard tried to account for the curve of the earth, he'd be wasting his time. He'd probably be screwing it up worse than he would be making it good. Especially since he had to be on the one side you could do it, and the other side you had to be on a boat to do it. So it's like you're on a boat in water trying to get something to the precision, of these little fractions of an inch. It's like, get out of town, dude. It's absolutely laughable. What they actually did is they had control points for the rails, and the control point has bolts that you can adjust, and it has a needle that's a certain length from the top, from the whatever device it is that's the control device. And what they do is they fill the trough with water, and then they turn the knob until the needle, with their eye, they see it, and they can look. I think they had a scope to look at it really, really high, close. And so what they do is they turn the knob until they see the needle just touch the surface of the water. Then they go to the next one and do the same thing, next one and do the same thing. That's all they do. They're just leveling it to the water, paralleling it to the water. That's all they're doing. So if you say I'm accounting for the curve of the earth by making something parallel to the surface of water, then you're just assuming that the water is curved, and you're assuming that the resultant will be curved. So that's just one big circle. It's not actually proving that it's curved.
What was that device you were saying? Atomic, like an atomic gyroscope or atomic accelerometer or something that would be able to determine its like dead reckoning.
Yeah. I think I heard about it within the past year. So it's basically like on the atomic level, like that is just my rough remembrance of it. So like on the atomic level, it's like a single atom or whatever can tell how it's moving for whatever reason. And supposedly they are getting to the point where they can track that and read it, and then it would tell you exactly how it's moving through space.
It's probably just using force equals mass times acceleration and then just integrating over the acceleration.
No, dude, it has nothing to do with that at all. We're talking about fluctuations within the signature of the atom that it's reading. So like as suppose like like you just similar to a gyro, when a gyro has a certain rigidity to it, and then when you move something around it, it can tell the difference.
Even that I think is using like angular acceleration.
No, it's not. The angular acceleration part of the gyro is just to spin the plate to get the plate to be rigidity in space. And then the only thing that matters is the relative motion of the case that the spin wheel is in. So it's not after you spin the wheel, it has nothing to do with F equals ma after that at all. It has to do with the orientation of the device.
Well, that's for a gyroscope, but we were talking about being able to measure distances in a similar way. Like if an object is moving from one place to another and it's able to determine how far it went. Seems like the only way it would be able to do that is by integrating its acceleration and then integrating the velocity.
What? It'd be an interesting read to read more about it, because it was only like more of a a short article blurb like this. This is something to research, and it's coming down the pipe eventually. They'll hope to have it, or they're certain they'll have it. I can't remember.
But we have pretty accurate gyroscopes. Like there's these ring laser gyroscopes. I was reading about some super sensitive gyroscope that they built that was supposed to be determining like wobble and wobble on the earth and everything. It seems like we
Sure.
do detect.
Yeah,
Do you
sure.
think
Cool story. So put it on a plane. Listen, put it on a plane. Take a plane in level flight from Boston to Los Angeles, and then show me that device is displaced radially in the amount necessary with traveling over a curved Earth. Because if your plane is traveling over a curved Earth maintaining level flight, then it's traveling in a giant arc. And that means the plane, in order to maintain quote unquote up, would have to constantly rotate. So if these devices exist that can measure that, then we should have hundreds of thousands of measurements of this arc, and all the airplane flights that have these devices on them. Not all do, but a lot of them do have the ring laser gyros. They have the D-Roof system on them. They have mechanical gyros. So where's all these measurements from the planes showing this rotation?
I think those exist. Let me look that up.
Yeah, well, I'll tell you what, friend, before you bother looking it up, and I'm not saying don't do it, I'm just saying before you do it, a pilot named Wolfie 6020 promised us that this data exists. He said, I'm a pilot. I'm going to prove you guys wrong because pilots know. I'm going to get you this data. That was like 8 or 10 years ago, dude. Still hasn't given it to us. In fact, the only data that's been brought up from planes doesn't show any rotational vector at all. It just shows a plane takes off, gets to level flight, it maintains pitch, then it alters its pitch accordingly, and then it alters its pitch and descends and lands. There's no proof that it rotated at all in any of the data that's available to the public. But like you
What's
said,
that? What? Sorry.
supposedly, like you said, Dylan, supposedly those systems are sensitive enough. And in fact, in the instructions or the talking about the Adiru, it says that the Adiru is capable of detecting those rotations that I was talking about and the pitch of the plane because they're orders of magnitude greater than each other. One is called the Earth frame rotation, and one is called the plane frame rotation. And the plane frame rotation, like true pitch, like hey, I want to pitch up 3 degrees, I want to pitch down 3 degrees. Like those are orders of magnitudes per second greater than the rotational attitudinal change of traveling in an arc path over an ever-changing radial down. And so these devices claim to be sensitive enough to have this information, but here's what they say they do with this information. They cancel it out. They go through a fusion algorithm to intentionally cancel out the Earth frame rotation. And here's the reason. So that the system can treat traveling across the Earth as a static reference shift rather than a dynamic rotation. So in other words, the system is canceling out the alleged curve of the Earth because you can just fly your plane as if you're flying in a straight line. Wow, that's funny.
They do that for the rotation of the Earth too.
Yeah, it's funny. It's funny how these things that are supposed to be there, you can just treat them like they're not there. Wow, that's so funny. It's almost like they're not there.
And what's
It's almost
that
like I told,
calculation?
listen, Dylan, I'll tell you, bro, but real quick, I was telling my friend for years that I'm married. And every time I go to the grocery store and I say I'm shopping for the groceries for the house, they notice how I don't buy that much food. And then one guy finally asked me, hey, how come you never buy food for your wife? It's almost like you don't have one. And I'm like, yeah, you busted me. I don't have one. Anyway, Boogie Woods. The calculation.
I was just trying. No, I was trying to mention that calculation for Dylan. What is it? The top of descent calculation. That's in aviation as well. That
Oh, yeah.
when they're getting ready to land, they got to calculate their rate of descent. I think it's called top of descent calculation. And they in that calculation they just assume the Earth is flat as well.
Right, it's called apparent drift from the rotation and transport drift from flying over the curvature. And they account for that apparently.
No, they don't account for
Supposedly.
it. Unless you're talking about alleged Coriolis drift. But in the systems that I just explained to you, the fusion algorithm deletes it before it even reaches the pilot's end user interface. And
Right.
the reason
That's what I
why
mean
they
by
do it, that's not accounting, dude. They do it so that the pilot. See, here's the thing, dude. Here's the thing. People say account for the curvature of the Earth, when really it just means irrelevant. That's all it means, dude. Okay, quote from the Adiru process. The Earth reference rotation or the Earth frame rotation is fused out through the fusion algorithm so that the plane travel can be treated as a static reference shift rather than a rotation. So they're treating the plane as if it's not rotating when the vector of down changes, as if it's just going in a straight line. So in other words, not traveling in an arc parallel with another arc, but rather traveling in a straight line parallel to another straight line. Almost like the plane's just flying in a straight line. Wow, that's weird.
Yeah, they're not trying to use their devices to measure the curvature of the Earth or to measure the rotation of the Earth. They're just trying to navigate their plane. So it ends up being like an error. If the Earth is rotating underneath them, you're gonna get some angle change, and that's not that would throw off your heading, you know? That would throw off your heading or your level flight.
That's a
So
cool claim,
they
dude. Where's
account,
the
yeah.
evidence that these planes are? Where's the evidence that these planes are ending up in totally wrong locations if they don't quote unquote account for this thing that they don't have to account for anyway because it's meaningless and negligible? I mean, dude, all I hear when I hear all this stuff is arguing why things aren't there. So, for example, I'm dating. Who's the hottest chick right now? Let's see. Who's the hottest chick people know? See if you get this answer right.
Zsa Zsa Gabor.
Oh no! Holy crap! Yeah, I'm dating Zsa Zsa Gabor, and
Lucky.
yeah, you know I'm dating her because she's not at my house, and the reason she's not at my house is because she's so busy. She doesn't have time to be at my house. So the proof that I'm dating her is the fact she's not at my house right now. Wow. It's like, yeah, the
It's like
Earth curvature is there, but it's not there. The proof that it's there is the fact that it's not there.
If we could show the mechanism, like break
just making
down the
people
code
know.
for how they're accounting for it, because if they're accounting or correcting for this directional shift and drift, then or transport drift and apparent drift, if we can show that they're correcting for these, then that is evidence that they exist, right?
No, they have to show proof that they're measuring them in the first instance.
Do you see the repeating pattern calculations built on assumption?
Oh, and good luck getting that data, dude, because that's a sealed system and nobody has anything to do with the airlines is allowed to mess with it. If it goes bad, they have to give it back to the manufacturer and it gets replaced with a new unit. These are sealed systems, dude. The pilot has no idea what's going on in there. The airlines have no idea what's going on in there. Yes. Those are the true black boxes. See, because there's this data out there called flat earthers erroneously call it the black box data, right? Because it's from the NTSB and it's from the flight recorder. Okay, black box data is black box. It means you don't get to see it. So if it's publicly accessible data, it's not black box data. The real black box is the pre-fusion algorithm alleged measurements of the alleged Earth frame rotation. Now, if you just had a device that could measure that was that sensitive, and you just brought it on a plane in your carry-on luggage, hey, you could measure it yourself. You don't need to take Northrop Grumman or whoever else manufacture these things. You don't need to take it. Don't need to take their word for it anymore.
Isn't it funny? It's available information where all these planes are flying and they're going to get there and all that, and that's fine and available to anybody. But isn't it funny that they're not transparent about something that I can't? I mean, can you think of a reason why they weren't transparent about that?
What's up, you guys? I'm watching the best movie of all time right now, bro.
Terminator 2, Judgment Day.
No, I'm watching Tremors, Cold Day in Hell.
Oh, the Tremor movies are garbage. They're funny, but
All right. Cool
They're
story,
so
but we
good,
were on
bro. They're so
topic.
peak,
I
bro.
know,
Burt
that's
Gummer,
great.
bro.
Yeah, get muted. You don't just get to show up, dude, and say I'm watching the best movie. You got to actually put in the work of having a conversation about the topic before you're in the right.
He said he was watching Tremors. I wonder if the worms dug with Earth Group.
No, dude, the PNS waves, bro. The PNS waves. All right, we'll give Goth a chance to talk about the topic.
So we're going to talk about Tremors, or what are we talking about?
Spoil it for you?
Oh no, I've already seen all the movies, so like honestly, you can't even spoil it for me. I just would say, in my opinion, it's one of the greatest movies of all time.
Welcome to Flat Earth.
No, he meant spoil it
Yeah,
for you.
welcome to
What
Flat Earth,
topic
guys.
you're supposed to be talking about, bro? I'll give you a hint. It's Flat Earth. There you go.
My favorite thing about Flat Earth is nothing makes sense on Flat Earth.
I mean, doesn't everything already not make sense, though?
No, everything makes sense to me, buddy.
Oh, yeah?
Yeah.
Explain, where does gravity come from?
It comes from mass.
No. It doesn't.
He did a nuh-uh, guys. Nuh-uh.
This guy, bro, he said gravity comes from mass. It's actually pretty funny. Dude, how does it come from mass if scientists to this day don't even know where it comes from?
Hey, Twonger.
You must have never heard of Einstein, buddy.
Oh, I'm
Hey,
well aware of
Twonger.
Einstein. That's a theory, bro. It's not an actual explanation where it comes from.
I know.
Hey, Twonger. You know how I know the Earth is flat?
How do you know?
Because you're not making any sense.